Questions 21 to 25 on the 2004 grade 12 AMC 12A. If the sum from n equals 0 to infinity of cos theta to the power of 2n is equal to 5, what is the value of cos 2 theta? So we have the sum from n equals 0 to infinity of the cos of theta all to the power of 2n is equal to 5. So let's first write this out and see what it looks like. Cos theta to the power of 0 plus cos theta to the power of 2, right? When n is 1, this will be 2. And then you'll have cos theta to the power of, when n is 2, it'll be 4, plus cos theta to the power of, when n is 3, this will be 6, and so on. It just keeps on going like that until infinity. And that whole sum is somehow equal to 5. All right, so the first thing I'm going to do is, instead of working with cos thetas all the time, let me just let cos theta equal x. And that will just simplify it a little bit. So this becomes x to the 0 plus x squared plus x to the 4th plus x to the 6th, and so on, all the way to forever, and that equals 5. Now, this is a infinite series, right? And how do you add that? I mean, do we factor? Is there a quadratic? Or how on earth do we add an infinite series? Well, you might remember, if the series is geometric and it's infinite, it can be added with the very cool formula, which is a over 1 minus r. A is the first term, and r is basically the common ratio. So how do you get the common ratio? Well, you just take the second term and divide it by the first term, or you can take the third term and divide it by the second term, like that. So in our geometric infinite series here, our first term is x to the 0, which is basically 1, right? Anything to the power of 0. Our ratio is x squared over x0, which is x squared. And just to be on the safe side, we can do it once more, x to the 4th over x squared. That's also the ratio, and that's also x squared. So therefore, r is definitely x squared. So now let's use our cool formula here, a over 1 minus r, and that is all equal to 5. A in our case, we just figured out, was 1. 1 minus r is x squared, and that equals 5. So now cross multiply, we get 1 is equal to 5 times 1 minus x squared. And this looks like 5 minus 5x squared is equal to 1. Put the 5x squared on one side. 5 minus 1 is 4. Therefore, x squared is equal to 4 over 5. X is therefore equal to 2 over the square root of 5. All right? So that means, since we let cos theta equal x, that cos theta is equal to 2 over the square root of 5. Now, that's not the value that they want. They want us to figure out cos 2 theta. It'd be nice if they only wanted cos theta, but they decided to make it a little bit more challenging and say cos 2 theta is what they want us to figure out. So how do we do this now? We've been thrown for a loop, right? And you might say, well, no problem. I'll just take out my calculator, figure out theta, and then multiply it by 2. Well, unfortunately, calculators are not allowed on the AMC exams. So without a calculator, how do I do this? Okay, not to worry. There is definitely a way of doing it, and I will show you how. So the first thing, of course, is without a calculator, I want to figure out a triangular relationship for cos theta is equal to 2 over root 5. So I'll let this guy equal theta, and in a triangle, the cosine is adjacent over hypotenuse. So this has got to be 2, and this has got to be root 5. And by Pythagoras, you can easily figure out that that's 1. Okay? So that's not going to help you figure out the value of theta, because I need a calculator for that. I can't figure out trigonometry without a calculator unless it's very obvious. But I still have to do this cos theta, 2 theta. Well, that's where you use your double angle identity. And some of you may remember this. Basically, the cos of 2 theta is equal to cos theta squared minus sine theta squared. There's a whole bunch of these trigonometry identities, and I definitely think it helps to memorize them, especially on the American exam, since you're not allowed to use a calculator to figure out trigonometry style questions. Okay, no problem. I know my double angle identity, especially now that it's written out. So let's figure this out now. Cos theta. Well, that's easy. It's 2 over root 5. I'm going to keep referring to my triangle there. Sine theta, okay, sine is opposite over hypotenuse, so that will be 1 over root 5, all squared. So this will be 4 over 5, and this will be 1 over 5, and therefore this is 3 over 5. And that is equal to cos 2 theta. So there you have it. So therefore this 21 is equal to 3 over 5, which is choice D. 3 mutually tangent spheres of radius 1 rest on a horizontal plane. A sphere of radius 2 rests on them. What is the distance from the plane to the top of the larger sphere? So I'm going to show you a question that is almost identical. The only difference is that all 4 spheres are identical in the question I'm about to show you. In this question, they just said that the top sphere has a radius of 2. So I'm going to show you that question, and then I'll come back and I'll solve this one. What is the height of this figure? A sphere is placed on top of the 3 spheres, touching each of the 3 spheres. All spheres are identical with a radius of 1. What is the height from the top to bottom as shown in the diagram? So the first thing I want to explain is the 3 spheres that are sitting on the ground like that. They have centers that are represented by these small dots. And those centers are joined by these lines. And that forms a triangle. And now we add a 4th sphere that is sitting on top of them. And that 4th sphere also has a center represented by that dot, and it is joined by these lines to the centers of the other spheres, like that. And that shape now is a tetrahedron. And that is going to help us figure out the height of this figure. And we are going to break up the height into 3 components. The first is from the very top of the top sphere to its center. We'll call that the first component. The second component is from the center of one of the bottom spheres to the very bottom, like that. And the third is going to be from the center of the top sphere to the base of that tetrahedron, right there. And if you add up these 3, they will represent the height from top to bottom of that figure. Now let's see what we can figure out. We are told that the radius of each sphere is 1. Now the distance from here to here is just the radius. So that distance is equal to 1. At the bottom, the distance from here to here is also just the radius. So that is equal to 1. Now we have to figure out this distance right here. And that I will call h. h for height. And then I will draw a line from the base of the height to one of the centers, so like this. And I hope you can see that now I have created a triangle that is a right triangle. And that one is like this. This is the triangle I'm referring to. And that triangle has a right angle right here. And therefore, if I can find this side, I can find h. Now what about this side right here? Well, that is connecting two centers. It's connecting the center of the top sphere to the center of one of the bottom spheres. So because it's connecting two centers, it is equal to 2r, 2 times the radius. And therefore that is equal to 2, since the radius is equal to 1. So now all I need to do to figure out h is find the value of that x right there. Now to find the value of x, what I'm going to do is I'm going to take this triangle that is representing the base of that tetrahedron, and I'll draw it over here. So here we go. And this is an equilateral triangle. Why? Because each side represents the distance between two centers. And the distance between two centers is 2 times the radius. And since the radius is 1, the distances are all 2. Now, where inside this triangle does the base touch? This base, where does it get to? Well, the answer to that is you have to draw perpendiculars from each side. So from the end, you have to draw up a perpendicular to that side, like that. From this side, you have to draw up a perpendicular to that side, and similarly, from that corner, a perpendicular to this side. And where they meet is that center point. That is where that height touches the base. So now I want you to look at this triangle right here. This is the length of x. Okay, the x that I have written there. In this diagram, that's where x is represented. Now this whole side is 2, and since I dropped a perpendicular to that side, I cut that side in half, and therefore this is 1 and that's 1. And then this is a right triangle, and if you remember, this was an equilateral triangle, so all the angles were 60 degrees. So that's 60 degrees. But I drew a line that cuts that in half, this line right here. So therefore, this angle in here will be 30 degrees. And since all the angles in triangle add up to 180, this is 60 degrees. Okay? And then I'll draw that triangle here just to make it a bit cleaner. This is 90, this is 60, this is 30. And do you remember the relationship of the sides in a 30, 60, 90 triangle? They have a ratio of 1, 2, and root 3. All 30, 60, 90 triangles have 1, 2, and root 3 as the ratio of their sides. So now we can use x and 1 and the ratios of those sides to figure out the value of x. So that means x over 1 is equal to 2 over root 3. And therefore x is equal to 2 over root 3. So now all we have to do is go back to this triangle and use the Pythagorean theorem to figure out the value of x. So we have h squared plus x squared is equal to 2 squared. H squared plus 2 over root 3 squared is equal to 4. And therefore h is equal to 4 minus, that will be 4 over 3. 12 minus 4 is 8 over 3 is 8 squared. And therefore h is equal to the root of 8 over 3. And now finally, the total height from top to bottom, total height was this right here, which is r, plus this h, plus this r right here. And therefore that is 1 plus 8 over 3, the square root of that, plus 1. So this is 2 plus the square root of 8 over 3. And if you want a decimal value, it will be approximately 3.633. So there you have it. That is how you figure out the height of that figure. So now I hope you have seen that video and I hope it helped you. So very similarly, our total height is the height from the center of the top sphere to the top, which would be 2 in our case. And then add to that the distance from one of the bottom ones, the center of one of the bottom spheres to the bottom of the diagram, which is 1. And then very similarly the height that you have to figure out. So this basically becomes 3 plus h, and now I have to figure out h. And just like in the diagram in the video that you just watched, h is going to be figured out with a right triangle. So this was h, and if you recall, this was x, and this side hypotenuse is basically the distance between the top sphere, the center of it, to one of the bottom spheres, the center of that. So it's essentially 2 radii. In this question, the top sphere has a radius of 2, and the bottom spheres have radii of 1. So this hypotenuse essentially is equal to 3. So our equation becomes h squared plus x squared is equal to 3 squared. Correct? And in a very similar way, to figure out x, we have to look at that base of that tetrahedron. And the base of the tetrahedron, remember, to figure out where the height actually touches that base, we have to draw centers. So we have to draw lines from the vertices to the other side to figure out the center. And if you recall, the x basically is right here. That's x. And this is a right angle. This is 30 degrees, and this is 60. And just like in the video, the ratio of the sides of a 30, 60, 90 triangle are root 3, 1, and 2, like that. And since this whole distance, in our case, is 2, each of these will be 1. Because this distance, if you remember, represents the distance between the centers of the 2 bottom spheres. And that basically means it's 2 times the radius, and the radius for each of those bottom spheres is 1. So from this triangle here, we can figure out that x over 1 is equal to 2 over root 3. So there you go. We've got everything we need. So h squared will be plus 2 over root 3 squared is equal to 9. So h squared is equal to 9 minus 4 over 3. And if you get a common denominator, this becomes 27 minus 4 over 3. And therefore h squared is equal to 23 over 3. And h is therefore equal to the root 23 over the root of 3. And if we go back, our total height in our question here is 3 plus h. And h is basically root 23 over root 3. Now that's not one of the answer choices because they have to rationalize the denominator. No problem. This basically gives us 3 plus root 69 over 3. 3 plus root 69 over 3 is answer choice B for number 22. A polynomial p to the x is equal to c 2004 times x to the 2004 plus c 2003 times x to the power 2003 plus dot 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 plus c1x plus c0 has real coefficients with c 2004 not equal to 0 and 2004 distinct complex zeros. Zk is equal to ak plus bki, and k is between 1 and 2004, with ak and bk real. A1 is equal to b1 is equal to 0, and the sum of ak from k equals 1 to 2004 is equal to the sum of bk from k equals 1 to 2004. Which of the following quantities can be a non-zero number? So first, a very quick primer here. I'll draw it here on the side. If you have any polynomial axn plus bxn minus 1 plus dot 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 all the way down to z, the sum of the roots can be calculated with a very cool formula, minus b over a, where this is b and that's a. And then the product of the roots can be also calculated with a quick formula, and that is it's z over a, where this is z and that's a. And this is true for even degree polynomials. And if it's an odd degree polynomial, then you just have to add a negative and make it z over a minus. Okay, so that's just a quick primer. So they want you to figure out which one of these can be non-zero. All right, so let's go through them one by one. First, A is C0. C0 is this guy right here. Well, they basically tell us that A1 is equal to B1 is equal to 0, correct? So that means my very first root, Z1, if I look at that, is going to be A1 plus B1I, correct? So A1, they tell me is 0. B1, they tell me is 0. And I'm going to multiply that by I. Well, Z1 basically becomes 0. Correct? So that means that one of my roots is 0. So if I go back and put it in here, remember, if you put in a value that is a root for x, p to the x becomes 0. Correct? So that means 0 is equal to c 2004 times 0 plus c 2003 times 0 plus dot 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 all the way till c0. And this all becomes zeros, and you're just left with c0 is equal to 0. Well, that means c is 0. It's not non-zero. So c cannot be a non-zero number. All right, in a very similar way, let's move on to B. C 2003. Okay, so C 2003, this is where we're going to use this sum of the roots. Sum of the roots is minus b over a, correct? Well, our b here is C 2003 and our a is C 2004. So minus b over a will be minus C 2003 over C 2004. So sum of our roots is going to be minus C 2003 over C 2004. Now the sum of the roots, if we write them all out, basically is like the sum from k equals 1 to 2004 of ak plus bk I, right? Basically, all the roots are of this form, so you're just adding them. 1 is equal to k, 2 is equal to k, all the way up until 2004. So let's separate this. This basically becomes a sum from k equals 1 to 2004 of ak, plus I'll factor out the I put the I in front. And then this basically becomes the sum from k equals 1 to 2004 of bk. Now, the sum of the roots is a real number, okay? It's real. So that means this whole thing has to be real. So the only way that can be real is if this is 0. If that's 0, then it will multiply by I, and that will also become 0, and therefore we'll just get a real number. We won't get anything with an I in it. That means it will be real. So the only way this can be real is if this is equal to 0. All right? So that means that the sum from k equals 1 to 2004 of bk must equal 0. Okay, so that just leaves us with this. K equals 1 to 2004 of AK. Well, where do we go from here? Well, they tell you that these two are equal, right there. So, if this is equal to the 0, that means that the K from 1 to 2004 for AK is also equal to 0. Therefore, that is 0. So, this means that minus C to the 2003 over C to the 2004 is 0. So if you cross multiply, you'll get C to 2003 is equal to 0. So this is also equal to 0. So that means that's out. I'm trying to look for something that's non-zero. Okay, let me just quickly do D, because D we already figured out. Right here. We just showed that is equal to 0. So that means I've eliminated D. So now I'm down to C and E as my possible choices for something that can be non-zero. So let me first look at C. B2, B3, all the way to B 2004. So C says B2 times B3 all the way till B 2004, like that. Correct? Now, they tell us in the question that B1 is equal to 0. So they tell us that A1 is equal to B1 is equal to 0. So our very first root, Z1, was of the form A1 plus B1I, correct? Well, if both of these are 0, this basically becomes 0 plus 0I, which is essentially 0. Now, for each of these complex roots, there is a complex conjugate that is also a root. So I wrote it out. For each of these complex roots, zk is equal to ak plus bki. There exists a complex conjugate, zk is equal to ak minus bki. That is also a root. All right? So that basically means that for our z1, there's a complex conjugate like that. Z1 is equal to A1 minus B1I, and that's also a root. So A1 and B1 were both zeros, right? So that means Z1, the conjugate, is 0 minus 0I, which is also 0. So that means that at least one of all the other B's has to be a 0. So at least one of the others, B2, B3, B4, up to 2004, has to be 0. Therefore, since B2 times B3 all the way to B 2004 is the product of all the other B's, and at least one of them is a 0, that product will be equal to 0. So therefore, we have now eliminated C as well. And by process of elimination, therefore this can be non-zero. So for number 23, the answer is E. A plane contains points A and B with AB equal to 1. Let S be the union of all disks of radius 1 in the plane that cover AB. What is the area of S? So this diagram represents basically the area of S. S is the union of all disks of radius 1 in the plane that cover AB. So that red circle that I just drew essentially represents one such disk. but that circle can be basically moved all the way about that blue boundary on both sides. And when you do, you create this egg-like shape. You can also start that egg at the bottom. And as you can see, this circle, if you draw it on the bottom, can also create that egg as you move it across the blue boundary there. So conceptually, it's a bit challenging, but this is basically that S region. So now we have to figure out the area of this. Okay, so how do we do that? We have to basically cut this into different sections. So I will label those sections. I'll call this section here A, and this is also A, like that. And then this equilateral triangle, I can just call that B, like that. And then finally, whatever is left is basically the other sector, and I'll call that C, like that. Okay? So the total area is basically going to be the 2A's, so that's pretty straightforward. So 2A. And then it gets a little tricky. You have to then add 2 C's. All right? But when you add 2 C's, you will double count the 2 B's. And let me explain. This is 1 C, correct? Right here. That region right there. That one right there. And the boundary is basically 1 C. And then if I add another C, like that, you'll see that those 2 B's have been counted twice. So therefore, I've got to subtract those 2 B's. So minus 2B, like that. Okay? So individually, we'll figure out A, B, and C, and then we'll come back and plug them into this formula. A is basically just a pie, right? It's like a piece of a pie. And this basically is 60 degrees right there, because if you draw a line from there to there, that's going to be 1, just like AB. So this becomes an equilateral triangle. All sides are 1. And because all sides are 1, that's 60 degrees. So how do you figure out the area of that pie? It's 60 divided by 360, basically 1/6, right, of pi r squared. And r is the radius of a circle that would basically create a circle about that curve. So that would be pi times 1 squared, and that would be 1/6 of pi, so pi over 6. All right, so that's basically just A for you. Now let's calculate C. C is in a similar way. You are going to take a section like a piece of a pie. If this was a big circle, this big circle that extends like that. Okay, not the egg, but a big circle. And this angle in here is very important. Well, that angle in there is 60 and 60, right? Because this is an equilateral triangle, so that's 60 and that's 60. So therefore that total angle is 120. So in a very similar way, you're going to have 120 over 360 pi, and the radius this time is from here to here, which is 2. So pi 2 squared. So this looks like 1 over 3 times pi times 4. So we have 4 over 3 pi. All right, so that is your C. And then finally, my equilateral triangle, right in there, this guy right there, that one I can figure out just by drawing a line from the top to the base like that. And that should be pretty straightforward to figure out 1/2 base times height. And this is, of course, a right angle. So we've got B is the area of an equilateral triangle, so 1/2 base. Well, the base is from there to there, which is 1. And the height we can figure out, because if this is the base and that's 1, then each of these will be 1/2 from there to there. And using Pythagoras, or a 30, 60, 90 triangle, whichever one you feel that you can do it more quicker, you'll be easily able to figure out that that height is √3/2. So √3/2 like that. So the B is √3/4. So there you have it. Plug them all into here and you'll get the area. So area, therefore, is equal to 2a, which is going to be pi/3, plus 2c, which is 8 pi/3, minus 2b, which is going to be √3/2. So this looks like 9 pi/3 minus √3/2, and that just looks like 3 pi minus √3/2. 3 pi minus √3/2 for number 24 is C. For each integer n is greater than or equal to 4, let an denote the base n number 0.133, all repeat to base n. The product a4, a5, ... to a99 can be expressed as m over n factorial, where m and n are positive integers, and n is as small as possible. What is the value of m? So first, let's explain what they mean when they write 0.133 repeat n. Well, what do they mean by that? Well, I'll give you an example. Let's say n is equal to 10. That means this is base 10. Correct? So this basically becomes 0.133. It just keeps repeating, right? That's what that line means. So this would basically be written in base 10, 1 times 10 to the negative 1 for this digit, plus 3 times 10 to the negative 2 for this digit, plus 3 times 10 to the negative 3 for the next digit, plus 1 times 10 to the negative 4 for that digit, plus 3 times 10 to the negative 5 for that digit, and then 3 times 10 to the negative 6 for the sixth digit, and so on. It just keeps on going like that. So they're saying that a to the n is this number to the base n, where n could be 4, 5, all the way up till 99. All right? So we have now a to the n is equal to 0.133, I'll repeat, n. And this is base n. Okay? So this basically becomes 1 times n to the negative 1 plus 3 times n to the negative 2 plus 3 times n to the negative 3 plus 1 times n to the negative 4 plus 3 times n to the negative 5 plus 3 times n to the negative 6, and so on. Because now n could be one of many numbers. So this basically means this is 1 over n plus 3 over n squared plus 3 over n to the power of 3 plus 1 over n to the power of 4 plus 3 over n to the power of 5 plus 3 over n to the power of 6, and so on. All right, ... keeps on going. So now we have to do a little bit of fancy manipulating, and that's the challenge of this question. I'm going to multiply everything here, both sides, by n to the power of 3. N to the power of 3. This whole thing. I'm allowed to do that because if I do something to the right side and I do something to the left side, that's perfectly allowable. When I do this, what happens? Well, on this side I get n cubed times an. But watch on this side, this becomes n squared, this becomes 3n, this becomes 3, this becomes 1 over n plus 3 over n squared plus 3 over n cubed plus dot dot dot. Now you say, well, what was the point of that? Well, this right here is the same as a to the n. I hope you can go back and convince yourself of that. And that is very helpful because now we can get rid of the dot 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 and just put a to the n like that. So here you go. We've narrowed it down to this. Okay? So now let's work with this. This now, if you put the an on one side, we'll get n to the power of 3, an minus an is equal to n squared plus 3n plus 3. Okay? Factor out an an, and you get n to the power of 3 minus 1 is equal to n squared plus 3n plus 3. And therefore, an is equal to n squared plus 3n plus 3 all over n to the power of 3 minus 1. All right? Take a second there to digest that. Now we continue with a little bit more of our magic. I'm going to multiply top and bottom here by n, like that. Okay? If I do that, I get the following. an is equal to n cubed plus 3n squared plus 3n. And on the bottom, I'll just leave it in factored form like this. And now one final magic step. I'm going to add 1 and subtract 1 on the numerator. If I do that, I can factor these terms, and they become n plus 1 to the power of 3. And then don't forget the final minus 1 like that. All over n times n to the power of 3 minus 1. Okay? So this is basically where you have to get to, this stage. I know that's difficult. I would agree. Anybody who says that this is challenging. Well, it's number 25 on the AMC 12, so of course it's going to be challenging. Now let's go back and see what is it that they want. They want this, a4 times a5 all the way to 899, and they want you to show that it can be expressed in the form of m over n factorial. Okay, so let's see here. I've got to show that this basically can be written m over n factorial. And what is that? a4 times a5 all the way to dot 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 a99. Correct? Let's see if I missed anything. Nope, that was right. a4, a5 all the way to a99. Okay, so what is a4 times a5 times a6 all the way till a99? Let's see what we get using this formula that we just figured out. Well, let's see. a4 would be 4 plus 1, so 5 to the third minus 1 all over 4 times 4 to the power of 3 minus 1, correct? And then you're going to multiply that by a5. a5 using this formula up here is going to be 6 to the power of 3 minus 1 over 5 times 5 to the power of 3 minus 1, like that. Let's just do a couple more. For a6, it will be 7 to the power of 3 minus 1 over 6 times 6 to the power of 3 minus 1, dot, 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 all the way till 99. When it's 99, it'll be 99 plus 1, which is 100 to the power of 3 minus 1. And the denominator looks like it would be 99 times 99 to the power of 3 minus 1. Okay. Now, good thing is a lot of these cancel. So for example, this cancels with that cancels with that, and everything will cancel. This will eventually cancel with that. And the only thing you're left with on the top is just 100 to the power of 3 minus 1. And you'll have basically all these guys, 4, 5, 6, all the way to 99. So 4 times 5 times 6, dot, 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 all the way to 99. And then you'll have this lone, don't forget about that guy, that's the one that didn't cancel, 4 to the power of 3 minus 1. Okay, so far so good. So the top becomes, oh boy, 100 to the power of 3 minus 1. So I think that's a million minus 1, so 9999, like that. And then the bottom, 4 times 5 times 6, dot, 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 to 99. And then 4 to the power of 3, 64 minus 1 is 63. Okay, we have to somehow show that this is m over n factorial, correct? Well, this looks very similar to a factorial, but we're missing a couple digits there. Well, no problem, I can add them. If I put a 1 times 2 times 3 here, right? That would be helpful. Can I do that? Sure I can. 1 times 2 times 3, as long as I do it to the top. 1 times 2 times 3, like that. Okay, so basically I just made that to make this whole thing into a factorial. So I made the denominator now 99 factorial. All right, and I still got this 63 here. And the top becomes, oh boy, you got 6 times 999, like that. Okay, got to do a little bit of math here. A little bit of math without a calculator. So we've got to figure out this whole thing right there. And if you do, you'll find that is 95238 over 99 factorial. Okay, great. I got it in this form. So they want me to figure out what is m. Well, therefore, m is 95238. Right? Let's go see. 95238 is not one of the answer choices. Okay. Well, why isn't it one of the answer choices? Well, they want n as small as possible. So perhaps my n is not as small as possible. Okay. This was my n. All right. So let's see if I can make it any smaller. 95238. How about if I make it 98 factorial and then I take out the 99 and put it there? If I do that and then I take those two numbers and divide them, I will get 962 over 98 factorial, like that. And this is indeed in the form m over n factorial, where n is as small as possible. Correct? Because if you went 97 and 98, 962 is not divisible by 98. So therefore, n equal to 98 is the smallest that you can get for n. So therefore, m is 962. And that means that number 25, the answer is E.